Hi there, welcome back. This is the brain that I have to dig into next, and quite frankly this is not something I look forward to, because with all the radios I've restored, I've only had to do this about 3 times, I think it was, where I actually had to open the RF can and chase around for a problem there. The reason I say I have to open it up is because I went around every peripheral that I could think of leading up to this particular part to try and, well, basically make sure that it wasn't something external at the front end before I actually got stuck in. And I'm now quite convinced that it isn't external, although I did find a few problems while doing the checking on the externals. I'll show you that on the screen in a bit, but there were a few problems related to wiring which someone had messed up, and there's also a case of a resistor that had burnt out. Both of those would have caused the unit to stop functioning. However, what I think happened is the unit stopped functioning because of blown components, and the rest of the damage was done trying to solve the problem, which they obviously did not, or not permanently anyway. So let's start from the beginning. Let me show you the schematic and show you what I've found so far and what I've done so far, and what has led me to conclude that I actually have to open this guy up. So here we have the schematic. This is the one part that gets the tail end of the part that we're interested in, and I have painted in the FM checking in this brownish red, right? So just to distinguish it from the red of changed components, it's brown. So some of the lines had been checked, as I said before, when doing the power supply checking. Others weren't. And the first thing I found was this resistor here was open. It's a 3 meg resistor. It feeds that section there, which has to do with the AFC, automatic frequency control. This has an automatic frequency adjustment. Basically, when you get it onto a station and you remove your hand from that tuning knob, you depress or you release those little white buttons, and the automatic frequency control sets in. And what this does is it produces a voltage which helps to adjust the oscillator to keep it on frequency. Now, this is great because it does help with tuning if you have weak stations, but it also has a lot more circuitry than one normally would have in these sections. And another thing I've realized while I'm here is that, as one of my subscribers mentioned, you can't figure out what kind of circuit this FM uses, whether it's a slope detector, whether it's, what circuit does it use. And it is a little confusing, and the confusion is actually increased by the fact that the tube is not wired as per the numbers on here. I've actually done a quick sketch which shows the actual wiring, and the reason this is different is because these diodes in here, two of them share the same cathode. Now that means that the way you wire it does make a difference, and if you have the patience to go through all this and get the data sheet for the EABC80 out, you'll figure out perhaps how that thing is wired. Right now that's not of too much interest to me because I just want to get it to work, and I don't believe that we have a problem with this section, and I'll show you why in a minute. So here we go. I've done this part, it's all been done and it's been checked, and I've actually opened up that can, that's third IF can, because I needed to change that capacitor, which I haven't painted in yet, the 5 microfarad capacitor. That's inside the can. You literally have to take the top off the can. You have to do this very, very carefully, because this does have the 2 transformers in there and some coils, and if you're not careful, you open those coils up and that just ruins your day. But anyway, that was done. Checked all the connections inside, or most of them, and it seems to be okay. So the next step was going backwards closer to the actual FM box, FM can as it were. to check that these connections were right. And I did find something wrong there. And that was, we follow from this page, this here, that switch there, this represents those little switches on the FM tuning knob, which activates and deactivates the automatic frequency control. So when you're tuning, it takes it out of automatic frequency control, and when you let go, it brings it in. That variable resistor here, it's wired as variable resistor, is actually to adjust the functionality of the AFC, so more active, less active. But anyway, I've checked all that. It's all fine so far. If we go a bit further back, there's a couple of things I noticed. That capacitor is not there. And the reason it's not there is probably because it was soldered onto the pins, the two pins or the two connectors that go into the FM box. And somebody definitely messed with that, as I will show you. But I have not looked inside this thing. I've simply checked the connections coming in. And the connections coming in are, it's actually quite difficult to see the numbers of the pins here, but this is 9 and 10, that's the FM antenna. Then we have this pin 2, or connector 2, is that connector that comes from the automatic gate and control capacitor to the grid of the ECC85. The other connectors are 1 and 6, which is the B+. So a power supply line comes here, joins these two resistors, and these are actually soldered onto that connector, connected to a common pin that's not used internally. And then those resistors go off to those two pins. That's there. And then we have these two pins in here, number 3 and 6 or 8, 3 and 8. Can't read this too well. It's very, very vague on the schematic. But I think they're in the right place, and by opening the can, I can make sure that they go into the right connector, because I need to make sure they go to the right point, because these two could well be reversed. I don't think they are, but they could be. What I did find wrong, and I haven't painted it in yet, is this here. Somebody had connected this point to ground, together with the ground for that capacitor there. Now this is part of that fine-tuning function of the AM, of the shortwave band, and it's right on the pins as well. This is internal, but this connector here, this capacitor is connected on the entrance to the can, and somebody had shorted purposely that point there to ground. I've measured these capacitors, they're perfectly fine. They literally read 33 and 47 picofarads. This resistor measures 68 kilo ohms. There's nothing wrong with that. All connectors there are fine, and I'll show you what I had to do next, because at this point I'm pulling my hair out, because I realize I'm pinning it down to the inside of this thing, which, as I said, I wanted to try and avoid. But to do that, I needed to make sure that everything outside of the can was working fine. And to do that, I needed to make sure that a signal coming in here got out the other side the way it's supposed to. So I'm going to set that up and show you what we've got, and I'll tell you what I've done. This is one of the connectors that I had to redo, and I did indeed find a problem here. What we're seeing here is, this is the RF out. It's a shielded cable. It's connected to that pin D at the bottom, which is an unused pin. It's used just as a common solder point. From there you get that 33 picofarad capacitor goes from B to D, and then there's a 50 picofarad capacitor from C to D, and then that tapers off. Between those two you got the 68 kilo ohm resistor. Now that's all that should be. There's a ground here behind this cable, which is the internal shielding grounded to the chassis of the radio. This yellow wire is the one that comes from the that goes to the shortwave tuning adjustment, and it has a 20 picofarad capacitor to ground, so that 20 picofarad goes to that ground wire, and that's grounded to the bottom. Now this ground wire was shorted to that bottom pin there. Now this was tacked in because I know I'm going to have to desolder this to remove the whole thing, but I just wanted to test it. So that's that side. The other connector has 10 pins, and you see the two resistors here that feed the B+ lines. This red wire is the B+ coming in. The other wires are, one comes from that AGC line, one comes from, and these two others come from the automatic frequency control, and there's one more that is actually the heater wire, because the heater ground for the tube is connected to chassis, and we have the heater wire coming in here. So all that's been checked. I've actually desoldered the AFC ones, because you can actually get this to operate without those two wires connected. It was doing absolutely nothing when they were connected. So the next step was to see if I had the possibility of sending a signal through this. And the way I normally do that is I take 10.7 megahertz output there, a carrier wave, which is the intermediate frequency for this set, as it is with many of the other sets. And I put it through a little coil, which I've made here, which goes over the tube, like so. That's what they call lightly coupling. And normally you would do this and measure a AGC voltage, so a negative voltage on that 5 microfarad capacitor that you have inside that last IF can. But what you can also do is put an actual FM modulated audio tone on here and listen to it, listen for it. So what I've done here is I have a 10.7 megahertz signal. This is the carrier wave. The amplitude doesn't matter now. I'm going to put 50 millivolts. Remember that it's lightly coupled, so it's not a direct connection. The modulation is FM modulation. The frequency that I'm modulating is a 600 hertz tone with a 75 kilohertz deviation. So what I'm getting out of here, when I activate this, is a carrier of 10.7 megahertz, which is the IF frequency, with an audio tone on it, coming out and going into the rest of the circuitry. And what I should get then is I should hear the tone coming out of the speaker. Do I? Actually, I hear absolutely nothing. The speaker's right near the microphone. I hear nothing. And I'm putting this right on top of the tube because what this would do is it would basically reproduce the effect of the mixing of the frequency coming in and the oscillator frequency, and giving me the difference, which is the IF. So I should hear something. Now, if I take this off and I do that, you can suddenly hear it, right? What I'm doing is I'm lightly coupling to the actual feed line going out of the box, out of the FM box, just close to the wire. And there's my tone. So I'm getting nothing from here, and I'm getting that there. So the next step was, by placing this there, I wanted to make sure the rest of the FM was working. So I did an IF alignment of the route that the FM signal would take. And what that means is I took the signal from there, from the can. It goes through the switching and everything else. It goes through the first IF, which are these two. The first FM IF transformer is this one. I put this on the scope and measured for the amplitude. And I aligned this to give me the peak amplitude and the best sine wave. I'm literally looking for a 600 hertz sine wave on the scope. I got the best that I could. I then went to this one and the respective one on the bottom, did the same. I had a problem with this one. There was too much wax in here and this guy wouldn't turn. So I had to open the can, remove it carefully, remove the wax. This is so tedious, it's unbelievable. It's like watching paint dry, but it has to be done. And I got this thing to align properly. So this one was aligned, that one was aligned. Now the last one is the tricky one, because one of these you have to align for maximum amplitude, and the other one is the actual discriminator. And the discriminator, you got to do it with the whole setup with two resistors and a voltmeter and get zero deviation, blah, blah, blah. The other way of doing it, the simple way of doing it, is when looking at the sine wave on the scope, align it, the bottom one, to give the best sine wave. In other words, the least distortion. That's really what you're doing when you're aligning the discriminator coil. So I align that and I get a nice sine wave on here. The problem is that sine wave is artificial because it's been produced by this thing while being touched here or being held here. So nothing is coming out of the box, nothing at all. If I put massive signal on here, like I think it was something like, you know, I had 50 millivolts. If I put this at 2 volts, I start hearing something. Can you hear that? 3 volts, 6 volts. This is 6 volts peak-to-peak signal going in there. It is lightly coupled, but that's the signal going in there. I get something coming out. Now, if I went close to there, see what I'm getting? It's too strong a signal, and it's going to swamp everything. So let me switch that off. But what this led me to conclude is because the signal was so strong here, it was actually bleeding directly to there, which means no signal is actually getting in here or coming out of here. So what I did then, sorry about this relating, but this is so hard to do and film at the same time that when you realize that you've got a lot of stuff to report. What I did then is I removed this guy, and the actual signal comes out, and I'll show you on the schematic. It comes out of pin 6. That is the mixed signal that comes from the front end amplifier, the oscillator, and mixing effect of this circuit. So the signal coming out of here has the the frequency coming in, the oscillator frequency, the sum of the two, and the difference of the two. It's a jumble of frequencies, but the important one for us is the difference between the two, which should always be 10.7 megahertz, with the audio superimposed on that by frequency modulation. So I went one step further and I fed a very small signal there, AC coupled obviously, because I've got high voltage on there, and I took the tube out. So I'm basically reproducing what the tube would do, and the signal should go along here, and it should go through this transformer, and it should come out the other side and get fed to that line that we know is sending the signal through. Well, I can make it strong enough that it actually gets through there, but when I play with this transformer, I get absolutely no effect. I don't think this transformer is coupled properly for some reason. It's not the windings opened, because this actually gets through and I can measure the continuity of that, but there's something wrong with this coupling, and I'm not sure what it is. I'm almost certain this thing isn't oscillating, so the oscillator's dead. Now it could be a number of things. It could be one of these capacitors and one of these trimmers that's opened. It could be all sorts of stuff, but I need to open this up and try and find it. And I really can't procrastinate any longer. I know that the type of signal I should get out of here is a very strong signal when I touch or when I lightly couple that little coil, that homemade coil, to the top of the tube. I have changed out the tube, the ECC85, it's not that. I've checked everything I can from the outside, and it's definitely nothing that I can discern from the outside. Now, bugger. I guess I'm just going to get on with it. I've replaced the EABC 80. I thought maybe one of those diode sections was gone. It's not. And anyway, it is working because I'm getting the signal going through. I can measure the AGC voltage coming out of that circuit by that capacitor. That capacitor there. This is the positives connected to ground, that's connected to that diode. You get a negative voltage whose strength, whose value depends on the strength of the signal. When I do the alignments back there to the other IF transformers, I can see that changing. My audio is going through, so Everything seems to be working okay here, but for some reason that thing's not working there. By removing these two, which I've desoldered at the other end, which is the automatic frequency control signal, I should still get this thing working. And anyway, when it was connected, I was getting nothing anyway. What this does, when it goes into the circuit, it goes through two 6.8K resistors. I've measured from there through there, and I get a diode check. But because I've got these two big resistors, I'm not sure that that's real. So yeah, I don't know. I have to... This would affect the oscillation if that wasn't coming in properly there. If this was wired incorrectly, because I can't really read these numbers. That looks like 2, that could be anything. I mean, literally, that could be anything. That's the clearest schematic I've got. So I can only check that they're wired to the right pins on the outside by opening this up. And that's obviously the first thing I'm going to do, is check when I open it up, because I do get voltages there. I get B+ there and there. There is a little hole in the side of the tube holder, which you can actually measure down. And I believe when you measure that, you're measuring here, this point here. You're supposed to have about 2 volts or something on there. I'm getting 0.5 or something like that. Very low voltage. So something is definitely wrong here. And I've waffled on enough, so I better get on and do it and keep reporting back. We'll get there. We'll get there. Okay, this guy's out. This has all been desoldered. All the connections. Very important. A proper record of what I desoldered has been made on there, just so we know what to put back. You can always check with the schematic, but more importantly, I'll know if there's been a mistake in the soldering, which may be the case. This wire here, this red one, is a B+, so just in case this thing gets switched on inadvertently, I've just taped it a bit. I've taped the dial cord on here. If you've had to rewind one of these, you'll appreciate that this could be a good precaution. If it comes loose, we know how to put it back, but it's always easier just to unscrew these and it just slides out. So that'll save us a bit of work, and the rest is really just 2 screws down there and on there, and this thing's out. All right, now comes the challenge. There's 2 screws in the bottom we need to undo. It looks like this whole thing slides out of here, so I need to remove these 2 resistors, and then there are screws on the sides here. You can certainly see somebody's been here. They actually made a note on the can for which resistor went on the bottom. And if we go up here, this thing has been soldered and desoldered. It looks like a few times. It's pretty ratty. But anyway, let's carry on. And here we are. The beast is out of the cage. Now, the reason I don't like working on this is that it's all very compact. Quite a bit of the stuff is soldered to the chassis. A lot of little wires going around from the coils. So you have to be very, very careful. But we can check continuity and we can check values. So yeah, this is it. And what I've noticed is that the plungers are working. You can see that there. That pulley at the top winds that coil. And I can see both plungers working. And you can see at the bottom, you have that pulley. So it's not a problem with the plungers. As we'd figured out, at least one of them was working because we had the fine tuning. Right, time to ohm this out. Check values, check capacitors. Some of these small capacitors could have died. And find out why this thing's not oscillating. All right. This mess is what success looks like. And this is the result of that success. Pardon the enigmatic tone, but I'm rather happy right now. And you can guess I'm rather happy because I've got FM back. And this was something that took me till 3:30 in the morning. Not that I realized the time, because once you're into this stuff, it just, you don't look at the clock. And when I finally wired this together and got some sound out of it, I happened to look at the clock and realized I had to move because I had a meeting at 9 in the morning. But anyway, we've got FM back. And we got FM back as a result of that dismantling that I showed you, and as a result of desoldering I don't know how many connections in a very tight space in there, of checking components that are absolutely minute in value. And here are some of the values we're looking at. 13 picofarads, 7.5 picofarads. Some of these capacitors are so small that you have to be very loose with the reaction to the results, because you can expect the results to be a little bit off. I mean, just a slight error of capacitance to ground on the leads would give you, 5 or 6 picofarads on a 10 picofarad capacitor. Anyway, everything was measured and soldered back. And then when you solder it back, you've got to check connections again to make sure that you haven't messed something up. And then when I put this back, I replaced these two resistors. Not that the others were faulty, but the others are 1 watts, these are 2 watts, and these come across as they fit cleanly in there. I cleaned up the wires, blah 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 blah, and I switched it on, and I've got FM. And the irony is that I found absolutely nothing wrong. This was scary. I mean, I realized I was getting to the end, and I kept praying that I was going to find a faulty capacitor, an open capacitor, and I found nothing wrong. So when I put this back, my hopes were not really up. I was convinced that I was going to get absolutely nothing again, and I really had no expectations when I switched it on, but there we go. There's one channel, one station. Now they're pretty weak. That last one was very strong, but some of the others are pretty weak, and I'll explain why in a second. But it's there.
Tudo é possível. Ligue já 800-291.
That one's very strong, slightly distorted. And the positions on the bands are not corresponding to where they should be. I realize that. This one you've just heard here is somewhere in the middle of the tuning range. The position of the pointer is somewhere in the middle of the tuning range, when in fact this is 88 megahertz we were listening to, which should be right at the other end. But that's not important. The important thing is we've got the oscillator working, we've got the mixing happening, everything is great. This is great. This is a great result. And the reason this thing is so off the charts in terms of alignment, RF alignment, is because when I removed the components in there to check them, values change. I do measure, for example, I'll measure a little trimmer cap. Take note of what value I read. Let's say, I mean, these things are 1.5 or 0.5 to 3.5 picofarads, and the instrument I'm using is this guy here, which is fairly accurate, but it's not absolutely accurate. But I'll measure what capacitance this thing is set to. I'll then twiddle it to make sure that it's functioning as a trimmer, and then I'll put it back to the original setting that I'd made a note of, and I will solder it back. But obviously that's not exact, and when you align, very, very slight changes on those capacitors can make quite a difference, especially in terms of the oscillation frequency and therefore the position on the dial, etc., etc., etc. Not important, we can sort that out with the RF alignment. The only thing that I realized was wrong was actually later. I realized that that connection that I pointed out over there when I said the ground was shorted, that is not in the schematic. But in fact, when I looked at some of the schematics of some of the other sets, which are very close to this one, there's the Opus 7, there's the Opus 2114, which I did in the past. They all have a connection to ground there, which gives it a ground reference. So I put that back. But that is the only thing. Well, it's not. There was no mistake here. So why was this thing not working when it's working now? Well, the only thing I can guess at is that in the desoldering and resoldering that I've done, I've corrected possibly some bad soldering. I might even have shifted a component that was inadvertently touching somewhere else and shorting a capacitor out, for example. Dry solder joints or actual physical positioning of the components could have an effect. You can in fact get this oscillator to stop working simply by having bad wire dress, having the components positioned too close to another component that affects it, and it could stop working. If you have a capacitor that is lying parallel to a ground plane, it'll have a different effect than if it's perpendicular to a ground plane. Now, that sort of thing is impossible to predict, but I could have done that in the resoldering, and it sounds crazy that you dismantle something to reconnect it all up without finding a fault, but sometimes that is what you need to do. You just have to put the work in, and as I said, when you're looking for a result, sometimes it's 3 o'clock in the morning, and it doesn't matter because the result is there. And this is the holy grail of this radio. The FM is the prime focus of this radio, especially, normally for me that's the case, but especially this particular case, which belongs to a lady who listens to FM. She wants the classical station on FM. She deserves it, and this radio produces a great result when it works, and now it's going to work. It's working, but we need to align it. Now what I need to do, and I'm going to take a break now with the video, because the next stage I want to document how I fix the alignments. What I'm going to do then is do a full alignment on the FM, do an RF alignment to get these the band tracking in the right positions again, possibly extend the upper band of FM a little bit, because the one we heard here, that first station we heard, was actually 101.6 megahertz. Now, this radio is designed to go up to a maximum of 100 megahertz. So we know we can stretch the end a little bit, and we know that's actually happened. So this could well be the case. This could well be that we can actually extend it slightly, maybe up to the 101.6. I won't go too far above it because that sort of makes it a little bit watered down. You can water down the reception. You can make it slightly more deaf if you stretch it too much, because the front end is tuned to a generic position in the center of the band. It's a wide band filter that we have in here at the antenna, and it is tuned normally in the 88 to 100. It's tuned to 95 or 94, whatever it is. So you don't want to overdo it, because then you're basically watering down, you're reducing the sensitivity of the front end. But we can extend it a little bit without much loss. So yeah, right, this is it. A few things I need to do after uploading this video. I need to clean up this bench, because I got to tell you, what you saw in the opening shot here is only part of the mess that was on this bench. I tried everything. I even had this is a little FM transmitter. It's made from one of those car things that you set the frequency and you can plug your your iPhone, whatever, or MP3 player at the end, and it transmits on the frequency. And it goes up to 108. But I even used that to test this, to try and get an artificial oscillator going here. So this thing was full of equipment and wires and tools, and I don't like working in that environment, so it's time I cleaned it up. Anyway, that's it for now. That's it for this video, and I'll see you again soon with the alignment of the FM and, you know, a few odds and ends that still need doing. I still need to get those components to change the capacitors, recap some of the amplifier stage. Haven't received them yet. I live on the island of Madeira. It's a paradise, but when you need something from Germany, it takes weeks rather than hours or days, and that's one of the prices you have to pay for living in a place like this. No complaints, just a fact. Anyway, thanks for watching, and see you soon.